Perfect. Perfect. All right. So welcome everyone. Let me just start my timer, making sure I don't go over it. That was a great presentation by Daniel. It was awesome. It's a hard act to follow, but I'll try my best. So what we're going to be doing here now in this session is looking at sentiment analysis. And if you do sentiment analysis, or if you're interested in doing sentiment analysis and you use the bag of words approach in particular, you've certainly come across a situation where you had to select a lexicon for your data. And as you, because I've been through it, I can imagine that it might be difficult to select from a plethora of available lexicons which one is the best for my data. And this is what this talk is going to be focusing on. As Ben mentioned, my background is in clinical psychology. I also have a postgraduate diploma in social and cultural anthropology. So as you can all imagine, my background is pretty much qualitative and with a lot of psychoanalysis in the midst. But for the past 5 years, so I'm originally from Portugal. I've been here in the States for 6 years, and for the last 5, I've been working as a consultant in adult education, as a technical trainer. You know, it's been giving me a lot of opportunity to not only see what people are doing in the business side of things, but also to explore a lot of different tools to perform data analysis. And my familiarity with R, basically I started learning R like a couple of years ago, 3 years ago tops, and it's been a very rewarding journey, not only because of the things that it allows me to do now with my research, but because of the community. Frankly, it's an amazing community. Our ladies, everyone has been exceptional, and so just a thank you for all of you for being so welcoming and so challenging in the things that you put forward. So in this talk, as I mentioned, we're going to be looking at how we can select which lexicon is the best for my data. And in order to get there, I just want to do a very brief overview of, what text analysis is, and a little bit to continue on what Mitchell did earlier on text analysis. He did a great job. So we're going to be just looking at what are the lexicons that are available to us, in particular in the tidytext package by Julia Silge and David Robinson. And then I'm going to show you how we can use inter-rater reliability or agreement measures to find the lexicon that best matches human scores. All right, I saw a notification in the chat room, but I'm good. So what is text mining? So we could define it as a set of approaches and methodologies that lie at the intersection of different fields, such as computational linguistics, statistics, and computer science. They use textual data as input, and our goal is to be able to extract information from textual data in order to generate actionable insight. And we do that in order to support data-driven decisions. Some of the most commonly used techniques include text classification, clustering, document summarization, and sentiment analysis. The sources of textual data are almost infinite. So we can look at digital or print media. We can look at blogs, newspaper, journals. Let's say you are interested in knowing how people are reacting to, the epidemic. You could look at, social media. What are people saying between themselves? If you want to look at product reviews, if you deal with surveys or questionnaires, text analysis is a very powerful technique. And inside text analysis, we have sentiment analysis. And as Lou has defined it, it is the computational studies of people's opinions, appraisals, attitudes towards specific entities, individuals, issues, etc. It allows us to the application of sentiment analysis allows us to extract subjectivity from text. So let's say that you are interested in knowing how people feel about a particular object, a person, a situation. So you can look at, you know, from the side of an emotional subjectivity standpoint. Let's say you can analyze how people, if people love something, they hate something, they envy or admire something. So we can look at it from a subjectivity point of view, and we can also look at it to extract polarity or direction, if something is positive or negativity or negative. In some cases, we can actually, depending on the dictionary or lexicon that we are using, measure the intensity of that polarity. So while some dictionaries only allow us to look at if something is positive or negative, others will use a scale, such as the Affin dictionary that goes from -5 to +5. So anything above 0 would be positive, but to what extent? What's the intensity? So any value between 1 and 5 would determine the intensity of that of that uh, um, of that of that sentiment. There's two main approaches in sentiment analysis. One is the lexicon approach, which is the one that we're going to be focusing on here. And what it does is it calculates sentiment in a corpora through the semantic orientation of words or phrases in the document. The users get to use or to pick different lexicons available to them, and those are usually user generated. So someone has provided those lexicons for them. And what you have inside those lexicons are the words and the particular score or subjectivity value attached to each one of those words. And we could define them as either being general purpose or specific purpose. So let's say, for instance, in my field of study, you know, if you're looking at extroversion or introversion, probably you want to use a dictionary that looks specifically at those two dimensions rather than a generalistic one that measures other dimensions. And then we have the text classification approach, which is basically a machine learning approach where you build classifiers from labeled instances of text and supervised classification tasks. Inside the approach that we use, there's also two techniques. So there's the bag of words that, in essence, what it does is break down sentences or paragraphs into tokens, into one unit words, and they're seen as unique features of the document. In this case, in the bag of words approach, the word order and the grammatical word type are not relevant to us. So it doesn't really matter, you know, the position of the word in a particular string of text or in a larger realm. One of the advantages of using a bag of words approach is that it's extremely easy to perform. It does not tax, you know, our computation, you know, at all. It's super easy. And then we have semantic parsing that looks at word syntax. What are the rules that define the components of a sentence? And it uses part of speech tags in order to identify words in a grammatical or useful context. It is much more sophisticated and complex, so the investment towards this particular technique is much higher than the bag of words. But in case you are only, you know, using text analysis or sentiment analysis in particular sporadically, or if it's something that you want to get into, I would definitely look into starting with the bag of words approach. Anyway, so I get distracted with the chat. I'm so sorry. Let me move it away. What are some of the challenges in the bag of words approach? Well, for one, it is insensitive to context. And let's imagine a sentence where someone says, like I've actually found this, if you love your body, you should not eat fast food. The bag of words approach looks at love, eat, and might consider that particular tweet as something positive. So most bag of words approaches, if they're just looking at one token at a time, might miss that larger context. such as intensifiers or negators, etc. And they require a pre-built dictionary or lexicon. So our focus here is going to be on which lexicon we should be using to score or to label our textual data. I am a huge fan of the tidytext package by Julia Silge and David Robinson. And this is like the Bible, like if you're doing a bag of words, using the bag of words technique, I would highly recommend this book, and the authors have generously made it available for free online. So if you want to look at it, go ahead. And it's based on Atlee Wickham's tidy data principles. What it does is it treats text as data frames comprised of individual words. And, you know, since we're going to be using dplyr in many familiar functions to us, it makes it very easy to manipulate, summarize, and visualize the text. Inside the tidytext package, there are 4 different lexicons available to us. So we have the Affin, the Bing, Loughran-McDonald, and the NRC. If you want to look at the dictionaries after you install the tidytext package, if you type in get _ sentiments, you will be able to see each one of those. To note that even though some of these dictionaries have shared terms, each one of the lexicons might rate the same word differently, and there might actually be an overlap between them. The lexicons that are inside the tidytext package were also validated differently, depending on the reason why they were created by the authors. So some of them were actually validated by the authors. They assembled a team and validated the terms, while others, they resort to crowdsourcing, using Amazon's Mechanical Turks. People were rating the words, and so that's how they assembled the values. We have the Affin lexicon, which includes 2,477 terms, and it rates them in a scale from -5 to 5. If you notice, there's only one term that has been labeled neutral. It's kind of like peculiar, right? Like only one term neutral. And then we have the Bing lexicon, which was developed by Lou, and it contains 7,800 terms. 2,000 of those are positive, and approximately 5,000 of those are negative. So you can see that there's a big discrepancy between the way that it evaluates text by looking at also the way that how many terms it evaluates as positive or as being negative. And then we have the Loughran-McDonald lexicon. So this lexicon was devised for use in finance and to analyze legal documents. It has approximately 4,000 terms, and it not only identifies sentiment, positive and negative, but it also identifies subjectivity in text by looking at 4 different emotions, such as constraining, litigious, superfluous, and uncertain. And then finally, we have the last lexicon inside in the tidytext package, which is the NRC. It includes approximately 14,000 terms, so that's the dictionary that has the highest volume of terms, and it rates terms not only in terms of sentiment, positive and negative, but also on 8 different emotions. Something to be aware of is that some words might actually have different ratings. So let's say the word anticipated, like I anticipate something, right? So the dictionary might look at anticipate and score that word as fear, surprise, and anticipation, right? So there's an overlap there. So I'm going to show you, a very brief, in a very brief way, how you can use, the tidytext package to perform your sentiment analysis, so that I end with how you can validate the lexicon that best fits your data. And what I'm actually doing is using one of the session, the therapy sessions that I collected for my master thesis, and I brought it into R. And as you can see, I collected not only the different talk turns for the therapist and patient and the corresponding text that they like spoke in this session. And I also took note of the start and end times for each of the talk turns. This took forever. Don't do it. You don't need to. But I was interested in knowing, let's say if a patient is depressed, does a patient who's depressed speak on average more or less than a patient who is depressed, who is anxious? So I was looking at also other dimensions here. So if I filter just for the patient talk turns, you can see here 3 of those talk turns where the patient, expresses that she feels nervous, that she just wants to be able to forgive herself. So we have the string of texts. And here's how you apply the sentiment analysis using the tidytext approach. Basically, what you do is you just tokenize the text column where you have the talk turn text, and then you remove the stop words. And what you end up is with a series of tokens in a vector. And then you join that vector with the Bing lexicon. So when you join that Bing lexicon, you will see that some of the words that the Bing lexicon does not have in common with the textual data in your data set, it just basically gets rid of those. And it evaluates the ones that it matches with. And in this case, our first word was like stuck. So, the lexicon evaluated that as negative, sad, negative, etc. So how do you choose the right lexicon for our data? So as you can imagine, creating a whole new lexicon from scratch is time consuming, is expensive, requires validation. It's a master task. So one of the ways that I found that you can actually evaluate if a lexicon is good for you was through the reading of this very recently published article. It was in July of 2019, where Simon Provost, basically what they had was an app where patients basically type, they input what they're feeling, what they're thinking, and a bot will respond to them. And they were interested in evaluating the appropriateness of that bot's response. And so that was a very clever way that, basically by looking at the inter-rating agreements or reliability measures, you could see if the bot's response was appropriate or not. So what I decided was that this would be very interesting to look also at the agreement between humans and the lexicons. So what can you do in your work in order to use the best lexicon for your data? So I would recommend, let's say that you have a text or a specific type of text that you, are thinking on evaluating using sentiment analysis. You perform the sentiment analysis, and you basically just gather a group of subject matter experts and have them manually score each a sample of the text that you want to analyze. And then you calculate the average for a particular text and use that value as the human rating. After you computed the average for the human rating, you can then compute how it agrees or disagrees with the rating that was generated by the different lexicons available to you. And in turn, what you will do is hopefully select the lexicon that has the highest level of inter-rater agreement. So I have 1 minute just to show you there's 4 different types of inter-rater agreement measures that you can use, depending on if your classification is nominal or ordinal, you'll use a particular one. If you have missing values, you can only use Krippendorff's alpha. There's different ways for you to evaluate them. So basically, I actually created a Shiny app for my users, so you can also do this. And using the rel package, you have the CRA function that will evaluate Krippendorff Krippendorf's alpha. So in this case, we had a 0.48 value, which is not very strong. And you can also use Cohen's kappa to evaluate the agreement between users and the lexicon. This was also 0.48. So not very strong, but this is a good approach. So thank you so much. I hope that was helpful. And if you have any questions, please, don't hesitate to reach out to me on LinkedIn, Twitter, and GitHub. I have not published my presentation on GitHub yet. I'll do that today. But hopefully this will allow you to use sentiment analysis with your data.